Hey everybody, welcome to the first video of our last chapter of M308 Algebra 2. We're going to be working with systems of equations and matrices this chapter. And we're going to be starting with what is a matrix, kind of an introduction. Make sure that you've got, you won't need your calculator for this one, so just make sure that you've got your note packet and you're ready to go. And let's get started. So we're going to start with what is a matrix. And it is a movie, it's a great movie, but what is a matrix for mathematics? A matrix is defined as an array of a rectangular array of numbers that are enclosed in brackets. So I'll write that down for you. It is a rectangular array of numbers enclosed in brackets, and we use these square brackets for this. Okay, and each number in the matrix is called an element. Okay, so in this case, this matrix that you see here with the A, B, the C, and the D in it has 4 elements. Okay, we're going to talk about the size of these and how we can name them and how we can discuss so we know exactly which element we are talking about. But this is kind of an introduction. I also want to point out that matrix, when you talk about plural, more than one matrix, we call them matrices. So that's the word for plural. It's not matrices, it's matrices. All right, moving forward. So naming and dimensions. Matrices are named with a capital letter. We always use a capital letter to name the matrix. So in this case, we're calling this matrix A. Maybe I can call this matrix matrix B. So when talking about a matrix and we use a capital letter, the elements have lowercase letters if we're just doing a general matrix here. Now the dimensions of a matrix are always going to be written in this form. So, but we write it rows by columns. So it's rows by columns. We count the number of rows and then we count the number of columns. Okay, so this one has 2 rows. So we have row 1 and we have row 2, and this has 3 columns. So this is column 1, column 2, and column 3. And that is where these little subscripts come from. This isn't really an 11. It's saying it's in row 1, column 1, and in row 1, column 2, and this one is in row 1, column 3. And then we go to the second row. So we have row 2, column 1, row 2, column 2, and row 2, column 3. So this tells us that we have a 2 by 3, and that's how it's pronounced, 2 by 3 matrix. The second matrix we have here has 3 rows and 2 columns, making this a 3 by 2 matrix. So this is a different size matrix. The little subscript is sometimes used and sometimes we just can talk about it on the side for the dimensions. Next thing we're going to talk about here, as just as an introduction to the matrices, is that matrices are considered equivalent or equal matrices if the values in the corresponding positions are equal. So if you see an equal sign, that is indicating that this position, which is row 1, column 1, has to have the same value as this position, which is row 1, column 1. So we can solve these by setting the elements that are in their corresponding positions equal to each other. And so this would be x equals 2. We could say y equals 1. We would have p equals -1 and q equals 0. So a very simple way of explaining this. Let's look at example number 2. Here I have a matrix, let's call this matrix A, and this has 2 rows and 1 column. And then I have matrix B, which has 1 row and 3 columns. There is no possible way for these two matrices to be the same because they do not have corresponding positions. The only one that could be the same would be the first row, first column, but since none of the others have a corresponding position, these two matrices are not equal, and this it's not possible to set these equal to each other. Let's take a look at a third example. So this example has 2 by 2 and 2 by 2, so therefore we would be able to set the positions equal to each other, the elements. So y minus 4 equals 2, m equals 9, x plus 8 will equal negative 7, and we already have 4 equal to 4. So this allows us to have y equals 6 as one of our solutions, m equals 9 is natural, and x equals negative 15. So we can solve for the elements within. This kind of gives us a basis of what we're going to be working with as far as just what the names are and how we can speak to each other about matrices. The last thing I want to share is something called a square matrix, a vertical matrix, or a horizontal matrix. Okay, so a square matrix is going to be one that is 2 by 2 or 3 by 3, where there are the same number of rows and columns, making it a square. A vertical matrix is made up of 1 column and as many rows as needed, but it has a single column. It's just 1 column. And a horizontal matrix may have as many columns as we need, but it has 1 row. So these are just very specific names, and you'll see them throughout the text. All right, that's it. Great job.